Hello everyone, my name is Vivin Abram, and in today's video we are going to do some numericals. So over your screen you guys can see there is a numerical. So let me just read that out so that you guys can understand it, right? Okay, so the numerical is saying that we have two identical metal sphere A and B. Yes, they are separated by a distance of r, and charge on A and B is Q. Okay, great. So the charge on both the metal sphere is actually Q, and they exert a force F on each other. Okay, that's the information that we know right till now, right? That we have two metal spheres, right? A and B, right? Both have charges Q with them, and they exert a force of interaction of F, obviously by Coulomb's law, right? Okay. Next part of the question is that we have a third identical sphere C, great, which is neutral, is first touched with A and then B, okay, and finally kept at the midpoint of both the bodies. Find the net force acting on C in terms of F, right? Okay, so I hope you guys understood the question, right? So basically we are going to use three different concepts here, right? So let me just write it down, right? The first, we'll be talking about Coulomb's law. Coulomb's law will be used, right? Second concept is the concept that we have learned in our previous video, one of the previous videos, that whenever we have two identically charged bodies and when they are touched, right, so the charges divide equally, right? So when you have, I'll just draw it down, right? So when you have two identically charged bodies, then charges divide equally, right? Charges divide equally. So that is one of the concept that we're going to use. And the third one is, because according to the question is asking us to find out the net force acting on C in terms of F. That means net force on C will be the vectorial sum of all the forces that is acting on the body C, right? Definitely superposition principle that we are talking about here, right? So superposition principle, right? So three things. First, Coulomb's law is used. Second, that whenever we have two identically charged bodies, when they are touched, then charges divide equally. Third thing is your superposition principle that is going to be in the play over here, right? So if that is understandable, let's go to the question. Okay, so according to question, we have two identically charged bodies. Let me call it body A, let me call it body B. They both have charges Q and Q, right? They are separated by a distance of R. Then obviously according to the question, the force of interaction between them is F, right? And how much will be that F? Let's try to find out. Obviously by Coulomb's law, yes, F is very simply, you can write K Q upon R square. Very simply you can write that, right? Or very simply you can write F is equals to K Q square upon R square. So this is something which we know, right? Quite plain, quite clear. There is no rocket science here, right? It's very simple. Coulomb's law, just apply it, right? Okay, great. Now the next part of the question is interesting, right? Next part of the question says that there is another sphere, identical sphere, which is neutral, and you call that sphere C, right? So which is neutral and it is touched. Let's say this is my sphere A, so there is this neutral sphere, C. Now this is touched with first one, that is A, then the charges divide equally, right? And then this body A will be having now different charge, body C will also have different charge. Now this body C is touched with body B, right? So let's do that. Let me draw that. Let's say I have this body A, right? This is my body A, which had Q charge, right? So now a neutral body C, which is again identical, right, in size, but it has charge 0, right? It is touched with A. So when it is touched, right, the charges will divide equally, right? So you can write new charge on body A. Body A will have a new charge now, right? So and what will be that charge? It will be equally divided, right? So body A already had Q charge, plus 0 is the charge on body C, right, divided by 2, or we can simply write Q by 2 will be the new charge on body A, right? Now very similarly, new charge on body B will be, very simply, 0 is the charge on body B, plus, okay, we are not talking about body B, I'm really sorry, this is body C we are talking, right? So body C, so 0 charge was there in the body C, plus Q was there in body A, divided by 2, or very simply you can write Q by 2. Now this is very important. Now both body A and body C have Q by 2 charge, right? Now according to our question, the same body which now had Q by 2 charge and now have A also has Q by 2 charge, now same body C is now touched to body B, right? So now you have this body B over here which had Q charge, and now you touch it with body C which has Q by 2 charge. Okay, alright, so what is going to happen now? Obviously both are identical, charges will divide equally, right? So new charge on body B will be equal to, very simply you can write body B had Q charge plus Q by 2 charge is because of body C divided by 2, or you can simply see over here, right? So 2 will be the LCM over here, this will be 3Q by 2 into 1 by 2, right? This will be 3Q by 4. So 3Q by 4 will be the new charge on body B, right? So body B will be having charge 3Q by 4, right? I hope that's understandable. Very similarly, new charge on body C, right? Body C already had Q by 2 charge, right? Plus Q charge was because of body B divided by 2, right? Same thing, you will get 3Q by 4. So body C will also have 3Q by 4, the new charge, right? So I hope that is understandable. Yes, right, great. Okay, so after this part of the question, this body C is placed at the midpoint of both body A and body B, right? So let's draw that, right? So here is my body A, right, and here is my body B, right, and दोनों के बीच में here is my body C, right? So let me name it body A, body B, and body C. Body A, as you guys can see, body A has Q by 2 charge, right? So I'll write it over here, body A has Q by 2 charge, body B has 3Q by 4 charge, body C has 3Q by 4 charge. I hope that is understandable, right? Okay, according to our question, the distance between A and B was R, and since body C is at the midpoint, that means this distance will be R by 2. I hope that's understandable. Very similarly, this distance is actually R by 2, right? So pretty clear till now, I hope, right? Okay, now our question is asking us to find out the net force experienced by this C body which is kept at the midpoint of A and B, right? Now it's pretty simple, you guys can very nicely understand over here that because all the three charges are positive, so all the three bodies are going to feel a repulsive force because like charges repel. All the three charges are positive. A has Q by 2 charge which is positive, C has 3Q by 4 which is positive, B has 3Q by 4 again positive, right? Okay, so these three bodies are going to feel the repulsion, but we do not care about body A, body B. Our question is we have to talk about body C, right? So very clearly body C is going to experience a repulsive force in that direction because of A. So force on C because of A, FCA, yes or no? Very similarly, body C is going to experience repulsive force in that direction because of body B. So I'll just write repulsion force at C because of, so you guys can see both the forces are 180 degree with each other. They are opposite. They are totally opposite. One is in this direction, another one is this direction. So the angle between them is 180 degree. Important. So angle between them is 180 degree, right? So here we are going to use superposition principle, because we are supposed to find out the net force on body C. Net force is simply, you guys simply write, net force on body C is actually vector sum of all the forces that is acting on body C, right? So first force is your FCB, right? Another force is your FCA. So you have to add them vectorially. That is what your final answer is. Yes or no, right? Okay, now for all those who have studied vectors in our 11th standard, I'm sure we all have studied vectors in 11th, right? So if we remember the vector addition, so let's say if I have a vector in that direction, I have a b vector in that direction, right? And the angle between them is 180 degree, then the resultant vector is simply, I'm talking about the magnitude here, resultant vector will be having a magnitude square plus b magnitude square plus 2a magnitude b magnitude cos of 180 degree, right? Cos of 180 degree. Now cos 180 is -1. For all those who do not know, cos 180 is -1. So when you put it over here, you will get resultant vector magnitude that will be simply equal to, this will be a vector magnitude whole square plus b vector magnitude whole square minus 2a vector b vector magnitude, right? And this is simply a minus b whole square, and when you finally get the resultant vector comes out to be, a vector minus b vector when we solve this, right? So this is the clear result, that is a vector minus b vector. First vector minus the second vector is your resultant vector, right? So very clearly you guys can see over here that I have vector addition over here, right? So if I want to find out, okay, let me use different pen. So if I have to find out the net force on C, this will be simply equals to FCB minus FCA. Simple. This is what will be my final answer, right? I hope that is understood. Now the only thing that I have to do is I have to find out the magnitude of FCB and FCA, right? I hope till now it is clear, right? So let's try to find out what is the magnitude of FCB and FCA, right? So obviously FCB, let's talk about that. FCB, that is force on C because of B, right? Force on C, okay, force on C because of B, right? I hope that is understandable, right? So you guys can see both have, so you can obviously, we can find out by Coulomb's law, right? That is K, and you guys can see there is 3q by 4, one charge, another charge is 3q by 4 again, divided by distance between them is r by 2 whole square, right? I hope that is understandable, right? Or you can write it FCB in magnitude is equals to, this will be 3 3s are 9 and 4 4 16, this is 9 by 16 q square upon, and let's talk about r square upon 1 upon 4, right? And that will come out here, this will be 4 by 1, so 4 4 16. So the final answer, let me write it over here, final FCB will be equal to 9 by 4 k q square upon r square, right? You guys can do it in your own copy so that you guys can see whether it's coming out to be that or not, right? So 9 by 4 kq square upon r square is coming out to be our result, right? And if you guys remember at the starting of this video, starting of the question, right? So your kq square upon r was your capital F, that was the original force of interaction, right? So I can write this term as F, right? So I can write FCB to be 9 by 4 times of the original force of interaction, right? Or simply original force of interaction, right? I can write it like that. I hope that is understandable, right? Great. So if that is clear, the second thing that I have to find out is the force of interaction because of force of interaction of C because of A, right? And that is again force of interaction of C, right, because of A, right? Again, you guys can see there is K, then there is 3q by 4, that is charge on C, then there is q by 2, that is charge on A, divided by r by 2 whole square, right? Very simple. So I can write FCA magnitude to be K. This will be again 4 to the 8. This is q square. Here you have 3 upon 4 to the 8 and r square into 4 upon 1 4 2. This is okay. So you will get FC. Okay, let me write it over here. FCA to be 3 by 2 kq square upon r square, right? This is something you will get, right? You guys can do it in your copy so that you guys can get the actual one, right? So that means, let me just write it over here. This will be FCA. FCA is actually equals to 3 by 2 times of kq square upon r square, and we all know this kq square upon r square is actually your original force, right? So your FCA will be 3 by 2 of F, right? I hope that is understandable. This is your first equation, this is your second equation. You got FCB, you got FCA. The final net, resultant net force on force of interaction on C will be simply equals to, let me write it, FCB minus FCA, right? You're talking about magnitude only, right? So this is something which you have to understand, right? Only magnitude here, right? So first one was 9 by 4 times of F minus 3 by 2 times of F, right? So you guys can do the simple calculation. Take 4 as LCM. This is 9F minus 6F, right? I hope that's understandable, right? Okay, great. So you will get 3F by 4 F net on C. I hope that is understandable. 3F by 4 is your final answer. Now again, important thing, it's a vector quantity, so definitely where is the direction over here, right? So let's go back to, okay, so you guys have to understand FCA was, FCA was 3 by 2 times of F, right? And FCB was what was FCB? Yes, FCB was 9 by 4 times, right? So FCB was 9 by 4 times of F, right? So you guys can see which magnitude was more powerful, right? 3 by 2 means 1.5 something, right? 9 by 4 means more than 2, right? So more than, it was actually more than 2, definitely more than 2, right? 2 se bhi zyada tha, right? So that means your resultant vector will be in that direction, because we have said in our vector classes that if you have 2 in this direction and 1 in that direction, right, and the angle between them is 180 degree, then obviously the resultant will be 1 in the greater magnitude direction, right? So very similarly here also the greater magnitude is your FCB, right? Direction will be from C to A, right? From body C to A, from body C to A, that will be your resultant direction. I hope that is understandable, right? So if that is understandable, let's move on to our next question. Second question. The second question says that we have two identical spherically charged metallic sphere. They are hung by strings and they make an angle of theta with each other in vacuum, right? So basically we're talking about mediums here, right? So we have two spherical spheres, identical spheres. They are hung by strings and they have an angle of theta between each other, right? And they are in vacuum, right? Now the whole arrangement is kept in liquid of density rho. Okay, the whole arrangement has been immersed into liquid of density rho. The angle remained the same. Calculate the dielectric constant in terms of densities. Density of metal sphere is sigma. I hope you guys understood the question. We are asked to find out the dielectric constant, right? So we know what is dielectric constant, right? Dielectric constant is dielectric constant of any medium is actually the force of interaction between any two charged particles or metal spheres. They are kept at some distance r. It is a ratio of force of interaction in vacuum to that of that medium, right? That is something which we have to find out, right? Okay, so let's do according to the question, right? So the question says that we have two identically spherically charged metal spheres and they are hung, right? So let's say this is my valve through which your metal spheres are hung. Let's say this is my first sphere, right? This is my second sphere. They are identical, by the way, right? Obviously they will be having a mass m, they are having mass m, they have charge, let's say q, they have charge, let's say q, right? Okay, the angle between them is theta, right? So obviously if angle between them is theta, if I draw a bisector which bisect the angle theta into, let's say, some angle alpha, which alpha is actually half of theta, right? So obviously I can, you know, draw it like that, right? Obviously because the bodies are the metal spheres are, you know, are being stuck with the string, right? So obviously there is a tension in the string which is obviously T, right? And also if this is alpha, then definitely this angle is also alpha, right? So I hope that's understandable, right? Okay, so if that is true, then the tension will have a component along the vertical. You will call it T cos alpha, right? Very similarly there will be a horizontal component which will call T cos, sorry, not T cos this time, this will be T sin alpha, right? I hope that is understandable, right? Okay, because of the mass they will experience the gravity, right? So mg will be acting in the downward direction, and also they have charge, both the bodies have qq charge and positive charge. That means they are going to experience a repulsive force also. So repulsive force will be in this direction, force on, let's say this was my body A, this was my body B, you know, repulsive force of body B because of A, or very simply I can write it, yeah, simply I can write it electrostatic repulsion, Fe also, right? It's one and the same thing. So that's how free body diagram, right? So obviously there is this mass m, charge q, right? So this is experiencing mg in the downward direction, right? There is T cos alpha in the upward direction, right? In this direction we have T sin alpha, and in this direction we have electrostatic force of repulsion, right? This is my FBD, right? Now again, this is when the body, or I should say the bodies, this is when the spheres are in vacuum. The sphere are in vacuum, right? That means there is no medium in between, they are in vacuum. Then the situation is happening, right? So obviously by free body diagram FBD we can very clearly see that T cos alpha will be equal to mg, right? And T sin alpha will be equal to electrostatic force Fe, right? Or very similarly, this is my equation number 1, equation number 2. Divide both the equation, you will get let's say divide equation 2 by 1, right? 2 by 1 you're dividing it, so you'll get tan alpha will be equal to Fe upon mg, right? This is one thing that I got, equation number 3, right? This is the condition when, you know, when both the bodies are kept in vacuum, right? Okay, great. Now situation is changed. Now the whole arrangement is kept in water, right? Now I have shifted my arrangement in water, right? So when I shift my arrangement into water, right, so this is my, these are my two bodies, right, A and B, right, and this time I have water in between. I hope you guys can follow, right? I have water in between, right? Okay, great. So obviously angle is still theta according to our question, right? I can write this as alpha, right? Again alpha, same thing, right? Now this time again q charge, again because of the string there will be a tension, right? So tension, this time tension will be different because it is in water, right? It's not in vacuum anymore, so let me call it T dash tension, right? So T dash tension will have an upward component which will call it T dash cos alpha, T dash cos alpha, and it has a horizontal component will be T dash sin alpha, right? I hope that's understandable, right? Obviously there will be mg because of the weight, right? Great. Also this will experience electrostatic force just like in the previous one, but this time this will experience one more force. Because it is in water, the water particles will push this body in the upward direction and it will provide a upthrust, right? So there will be a upthrust in upward direction, let me call it u, right? So very similarly I can draw the free body diagram. Mg is acting in the downward direction, right? There is this T dash sin alpha, there is Fe, right? There is T dash cos alpha, and there is u. This is my FBD, right? And with the help of FBD I can write, okay, so I can write T dash cos alpha plus upthrust is actually equal to mg, or T dash sin alpha, or it is not or, just a minute, this is and the next equation is T dash sin alpha, which is equal to Fe. I hope that is understandable, right? These two will be equal, these two will be equal, right? Okay, great. So I can write this one as T dash cos alpha is equals to mg minus u, right? I can write this one as T dash sin alpha is equals to Fe, right? This is my equation number 4, this is my equation number 5. Again I can divide them, right? Divide equation number 5 by 4, right? So when you divide it you will get again tan alpha is actually equal to Fe upon mg minus u, right? Now very important thing, this electrostatic force over here will not be same electrostatic force that we talked about in the vacuum case, right? Because the medium is changed, so electrostatic force will also, so I'll just, instead of Fe I will write it Fe dash, right? So I will write it Fe dash, right? So everywhere I will write it Fe dash. Let me write it Fe dash. So this is Fe dash upon mg minus u. I hope that is understandable, right? Great. So this is my equation number 6, right? So if you guys remember, I want to find out dielectric constant in terms of densities, right? In terms of densities of your water as well as your vacuum, right? So okay, great. So we know that dielectric constant is given as force in vacuum upon force in medium, right? That is something which we know, right? Okay, so I have to do this, right? Now before that there is this mass term that is coming in between, right? Very in this case also, in this case also, right? So let me write both the third equation. So according to equation 3, which was in vacuum case, right? So you guys can see this is the vacuum case. Third equation, tan alpha was coming out to be Fe is equals to mg. Tan alpha was coming out to be Fe upon mg, right? This was my equation number 3, and equation number 6 is tan alpha is equals to Fe dash upon mg minus u, right? Okay, great. Now you have to understand over here that Fe is fine but your mass can be written, right? Because this mass is actually the mass of the body, right? And also the mass of the body has a density, that is sigma. Sigma is given as a density of the body, right? So I can write this, density is equals to mass upon volume, right? Mass upon volume, right? So sigma density is given, let's say it has a volume v, then mass can be written as sigma times of v, right? So I can write here this as sigma times of v times of g. Your mass has been converted into sigma times v, right? I hope that is understandable, right? Very clearly. And I can write for this case also, because in this case also we are talking about the same thing, right? So I can write this as Fe dash upon sigma times of V times of G minus upthrust. Okay, now upthrust is actually again a force, upward force, right, by the water molecule, right? So if this is my body, so there will be water molecule, right, and these water molecules will provide a upthrust to this body, right? Is actually a force, right? So I can write it F is equals to mass into acceleration for that also, for upthrust also, right? And again mass for that particular, actually mass is for water, right? Because we are talking about water, because water is providing the upthrust, right? So the mass of water can be given as density of water multiplied by the volume of water, right? And what is the acceleration over here? Acceleration will be g because of acceleration to gravity, right? So your upthrust can be also written as rho v g. I hope that is understandable, right? So instead of upthrust I can write it rho v g. V is actually the volume, g is your acceleration due to gravity, right? Okay, great. So I got two things here. First is by equation 3 you got your tan alpha to be Fe upon sigma Vg, right? And by equation 6 we got our tan alpha to be Fe dash upon sigma Vg minus rho Vg, right? I hope that's understandable, right? All we have to do is equate both of them, tan alpha दोनों को equate कर दो. You will get Fe upon sigma Vg is equals to Fe dash upon sigma Vg minus rho Vg, right? Okay, great. So G will be cancelled out from down. You will get sigma times of V, and V will also get cancelled out, right? So G and your V and G will cancel out, right? So you'll get Fe upon sigma is equals to Fe dash upon, this will be sigma minus rho, right? I hope that's understandable, right? Now we have to talk about dielectric constant, right? So dielectric constant will be simply Fe upon Fe dash, and this will be sigma upon sigma minus rho, right? So Fe upon Fe dash is actually your dielectric constant K, right? And that is equal to sigma upon sigma minus rho, right? So we got dielectric constant in terms of densities of material as well as water, right? So here is our answer, right? I hope you understood the question. If you have any doubt you can comment it down, right? I will try to answer them, right? And I hope all of you are doing good. Stay home, stay safe.